Okay, let's kick this off. Welcome, everyone. You are in Clicker Work, Discovering Azure Tooling and Utilities. My name is Jeremy Lickness. I'm a cloud advocate at Microsoft, and I'll be your guide through this tour of some of the tools and utilities you can use to increase your productivity for Azure. There's a little bit of a photo op in the beginning if you want to take a picture of some of these links. These will get you all the resources related to this session. You'll have access to this deck, and I'll also show these links at the end, so don't worry if I go ahead and flip through and we continue on. I want to start with painting a picture. By now, I think most people realize the cloud is really a set of data centers around the world, right? And on top of those data centers, in Azure, at least, we have one or two infrastructure as a service offerings that we can provide for you. And then on top of that, we have platform as a service, serverless, things like fully managed databases, things like web applications, things like networking, et cetera. And then across the sides of all these, we have management and security. Now, painting that picture, it can look a little bit overwhelming. There's a lot of services to manage. There's a lot of information out there. The purpose of this talk is to introduce you to some tools and utilities that hopefully will make it easier and more practical to navigate this map of different services that are available. What we're going to cover over the next 45 minutes is Visual Studio Code, and specifically the Azure Toolkit extension. I'll talk more about what that is. We're going to take a look at Azure Cloud Shell, and it's very tightly coupled with the Azure command line interface. We'll dive into how Azure works with PowerShell, and we'll close out looking at Azure Resource Management templates. Now, the goal in 45 minutes is not to make anyone here an expert in any of these areas, but to give you enough exposure that you have an idea of what you might want to take a deeper dive into later on. So let's get started with the first part of this, Visual Studio Code. Just out of curiosity, how many people here are currently using Visual Studio Code? So if you look around, that's a lot of hands. I've watched that adoption grow exponentially over the past couple years. If you're not familiar with Visual Studio Code, this is a cross-platform, open source, free, lightweight editor that allows you to develop, debug, and document applications. The nice thing about Visual Studio Code is it's built with a philosophy of adding exactly what you need. So it's extremely lightweight, and you put into it exactly what you're going to use and what you want to get out of it. So what can you use it for? Pretty much any modern language that you might be working with is supported through Visual Studio Code. And it also has extensions that allows you to work with management features like PowerShell and Cloud Shell, as we'll show later. So why would I consider Visual Studio Code? The first major advantage is that you can do pretty much everything from the editor. I'm able to be extremely productive without having to jump out into a different tool or a different place. I can get everything done in one place. Second is that you can completely customize your experience. You can choose the extensions, the add-ons. You can choose the look and feel, the color, the fonts, the icons. So you can own that experience and how you want to be most productive. And last but not least, there's extensions for pretty much everything, and we'll take a look at that. But what's nice about Visual Studio Code is not only is there a huge marketplace of existing extensions, but it's straightforward for you to write your own extensions as well. There's templates and guidance and walkthrough. If there's something missing, you're able to contribute and build that. So when we talk about doing more from the editor, some of the things you can do without leaving are edit code. You can manage source control, and that includes infrastructure as code that you might have checked in. You can debug. You can use a built-in terminal. And with Live Share, you can collaborate with other individuals who have Visual Studio or Visual Studio Code. Even if they don't have the same platform or the same extensions, they're able to connect to your experience, to be able to walk through, to edit code, and to debug. So it's a very powerful experience. Everything's customizable, starting from the color to the fonts, icons. You can choose what syntax highlighting you use. You can install your own formatter. So if there's a certain way you like to format code, You can probably, I haven't tweaked this setting, but choose tabs versus spaces if that's something that's important to you. And you can set your own key bindings, so your own shortcut keys. You can also set up snippets, so you can have a sequence of keys that generates a piece of code that's commonly used. When we look at extensions, we have everything from a linter, which takes a set of practices and rules and applies it to your code base. Not only tells you what you've done wrong, but in many cases offers ways to refactor the code to fix that. You have support across programming language and debuggers. You have formatters for formatting the code, how it's laid out. And then there's plenty of extension packs. Extension packs are pretty neat. They're extensions of extensions. So what I'll show you with the Azure Toolkit is actually a set of extensions that are all bundled together. So I'm going to jump in and show you an instance of Visual Studio Code that I have up and running. Now this is open to a repo that just has a few things in it, and I've got a markdown file that's open here in the right-hand pane. A couple things I want to point out. Visual Studio Code is automatically figured out based on my extension that this is markdown. But if for some reason I needed a different language, I can just click on this, and you can browse through the different language extensions that I have installed on my version of code. So you can see that there is a lot of support for that. Now, if we take a look at this, I mentioned being able to customize everything from fonts and themes. Now, I know in general in presentations, a dark theme doesn't always appear as clearly on the screens. These are pretty big screens, so it's probably not a problem. But if I wanted to change that, I just open my palette. That's Control-Shift-P, and I can jump to pretty much anything just typing a few phrases. You can see I've been into the color theme, so I can open that, and I get a dynamic preview of the different themes as I move through these. And so we can switch that to a light Visual Studio theme, and there we've dynamically changed that. Another thing you'll notice is as a markdown file, it's recognized this, and it lets me open a preview. So I get a live preview on the side, and as I'm editing this, the live preview updates in conjunction with that. And then if we come over here, we can see I've got a bunch of tools down the left-hand side, and I've got these sections here. These sections show me quickly what's open, what I'm actively editing. They'll show me my file system, and what I can do in my file structure is, let's say I'm searching for something quickly. Now, I kind of cheated because I opened the folder with CSS, but if I was curious about Bootstrap, I just start typing it, and it'll highlight the files that I'm looking for. If I hit enter, it'll open the first file that's there, and you can see it's syntax highlighting the CSS because it's a CSS file that I opened. Of course, I can search not just over file names, but I can search inside a file. So if I'm curious about where I have H1 tags within my project, this quickly shows me that I have index.html. It highlights the code for me, shows me exactly where that is, along with, for example, some CSS, which quickly shows me how that code's being formatted. I have full source control integration. Now, out of the box, the Git integration is what's shipped. You can configure other source providers as well, but you can see from this drop-down, anything I want to do with Git, I have available to me. I have a debug experience. Now, I don't have an application pulled up, so I don't have a debugger configured, but what's nice about Visual Studio Code is it understands the context of the project you're in. And if I click this little cogwheel right here, what this will do is it'll automatically set up a configuration file for me that gives me everything I want to debug. For example, if I'm using a Node application, I want to launch Node and hook into the Node debugger. So that's available for that. These are the mini extensions. I have 28 extensions enabled right now on my system, and I can scroll through these. But if I was curious, for example, what can I do with Node.js, I can just type Node, and it'll pull back all of the different extensions. And then when I highlight those extensions, it gives me information such as how many times it's been downloaded, what it's rated. I can see information about it, screenshots, etc. When you install different extensions, some of those appear as new tool items. So for example, I can work with my Docker containers here, but what I want to focus on is this Azure toolkit. So this extension has several different extensions inside it. So I have API management, I have app services, which is the platform as a service where I'd run web APIs and web applications. I have functions, storage, Cosmos DB, IoT Hub devices. Here you can see I've opened up an app service called Tailwind Traders Static. I can look at things like application settings, deployments, etc. I'm just going to right-click and go to Browse Website to open that. So it's prompting me, I'll open the link, and you can see I created just a simple static website for Tailwind Traders. Now what I can do with that is I can come back into my file editor, and I'm going to open up the main index.html page. Now, I'm inside HTML, so Visual Studio Code is automatically giving me IntelliSense, showing me what's available as far as HTML tags. I'm going to go ahead and pick an H2 tag, and I'm just going to type straight from Visual Studio Code. So we'll save that. And then, although you've probably heard friends don't let friends right-click publish, the first time you're working with an application, it's probably useful to test it out to make sure it works. So what I'm going to do is go back into this Azure tab. I'm going to right-click. I'm going to say Deploy to Web App. It's warning me that it's going to overwrite what's there. I'm going to say go ahead and deploy. It says check the output window. So if we look at that, this is just a static website. So all it's going to do is zip up the static assets, upload those into the site, run a script to make sure it's aware of the new files, and then restart that app service. So now it says it's completed. If we come back over to our web page and we refresh, we can see that I published straight out of Visual Studio Code without having to leave that. The other thing that I really like about Visual Studio Code is if I hit Control backtick, let me actually collapse this down for a second. If I hit Control backtick, I can open an integrated terminal. Now I've got Git Bash configured for mine, but I can change what that default is. In fact, I can even open a terminal called Cloud Shell. We're going to talk more about Cloud Shell in a minute, but what Cloud Shell is, it's a fully self-contained shell that I can navigate to that's backed by Azure Storage. So what that means is I can access that from multiple places and have a consistent experience with that. So this is connecting to the terminal, and I was about to show you my trick of moving the mouse clockwise to speed it up, but it jumped the gun. But so you can see that I'm in a Cloud Shell, not on my local laptop. If I look at my node version here, this is 8.16 that's pre-configured in the Cloud Shell. Whereas if I look at the version on my local terminal, this is 10.16. So two different versions, but a shell without having to leave Visual Studio Code. So I'm going to pop out of this because the next thing I want to talk to you about is Cloud Shell and the Azure Command Line interface. Now these are two different features, but they're very tightly coupled. I can use the Azure Command Line interface in multiple places, and that is a way of, from the command line, provisioning, querying, and interacting with Azure resources. Cloud Shell provides me a pre-bundled experience that has pre-installed developer tools that I can get up and running with right away. It's a browser-based shell, so there's a couple different ways to navigate to it that I'll introduce you to. And it also has two flavors. You can use Bash, which is one of the Unix-style prompts, or you can use PowerShell inside of Azure Cloud Shell. There's multiple ways to access it. If you look down the left-hand side, you can see you can get it from the portal. You can navigate to a website. Our documentation has Cloud Shell integrated with it. So certain documents will allow you to open a Cloud Shell instance and run commands right there without leaving the documentation so that you can test out what you're learning. It's part of the mobile app. So if you're on the run and you need to do something quickly in the shell, you can do that right from your phone. And there's an extension that I just showed you in Visual Studio Code that opens that up as well. You can pick Bash or PowerShell, and because it's backed by storage, wherever I access that Cloud Shell, I'm going to get a consistent experience. So how I set it up is available everywhere I access that. These are some of the clients that are pre-installed. It's not installing a Docker server, but it does install a Docker client so I can connect with a Docker host and perform Docker functions. Things like a MySQL client, Kubernetes, etc. So I'm going to show you a quick demo of Azure Cloud Shell. There's a few ways we can get to it. If I look at my dashboard, the first thing I'll point to is up here, we've got a Cloud Shell prompt right inside the portal. So if I click on that prompt, it's going to split my portal. It's going to open a panel on the bottom, and this will request a Cloud Shell. You can see I have a drop-down that I can switch between Bash and PowerShell. So that's one way to do it. Another way to do it is I can go just straight to shell.azure.com. That's going to open up a full-screen terminal for me from any browser. We'll give it a second to come in, requesting Cloud Shell, and boom, same experience right there. I'm going to launch it from one of my favorite new tools. Is anyone here using the new Windows terminal, out of curiosity? So a lot fewer hands. If you've got a Windows machine, this is specific to Windows, there's a new terminal that's been released that allows you to customize the experiences you have. On my terminal, for example, I've got options to go to PowerShell, Command Prompt, Azure Cloud Shell, Git Bash, Node Command Prompt. So I'm going to pick Azure Cloud Shell, and that's going to integrate directly in this terminal. And we'll let it request it and pull it open. So first thing I'm going to do is come back to my Visual Studio Code, and if I go back to my Files tab, I've got a couple scripts here. This is a set of Azure Command Line Interface steps. This first step is a step to create a resource group. I'm going to run this step, and then I'll come back and explain it. So let's kick that off, and that happened amazingly fast. So it's created the resource group. I said, basically, I want a resource group, give it this name, my ACI demo, put it in the East US. So if you're not familiar with resource groups yet, these are logical containers for resources in Azure. Before you can provision a resource, you need to provision it to a container. What's nice about containers is they have their own life cycle. You can manage costs at a container level, you can delete at a container level, and you can manage deployments at a container level. So the next thing I'm going to do is run the second command, and again, we'll kick it off first. We'll let that run, and I'll break it apart. What I'm doing is using our Azure Container Instance Service. So this is probably the fastest way to get up and running with a Docker container. You don't have to install or configure a Docker host. It's a service that's built into Azure. I'm putting it inside the resource group that I just created. I'm giving it the name my container. I'm telling it what image to use, which is a public Hello World image that Microsoft has. And then I'm telling it to prefix the DNS. So it's giving it a URL, and I'm telling it what to prefix that URL with. So if we zoom back out and come over to my shell, it's still running, and it just succeeded. So I'm going to come up here and actually grab this endpoint. So we'll copy that, come over to our website, and paste that in. And you can see we're up and running with a new web app just like that. That was live and not pre-provisioned for that instance to appear. Now, I did mention that Cloud Shell allows you to use Bash, which was the terminal I was just using. It also comes configured with PowerShell. The Azure module that lets you interact with Azure resources is available in several flavors. So how many PowerShell users do we have in the audience? A lot of PowerShell users. It's a very powerful tool for administration, for provisioning, for managing devices. And PowerShell 5.1 is a Windows-specific version that supports the Azure module, so you can interact with Azure resources from that. There's also the newer PowerShell core that's multi-platform. It runs on Linux, on Mac, and on Windows. It's also supported the same way from that version of PowerShell. It works inside Azure Cloud Shell. One of the advantages to using Azure Cloud Shell for your PowerShell experience is that it's frequently updated, so you don't have to manage those updates. You're getting pretty much close to the latest version just by using Azure Cloud Shell. What I'm going to do is jump back into Visual Studio Code, and I've got a PowerShell script. I'm going to take this first script, which is the way of provisioning a container using PowerShell. I'm going to open my PowerShell terminal, and I'm going to paste this in and run that. And I'll break it down. So this is a PowerShell command to create a container group. That's how you access container instances. We're using the same resource group that I provisioned earlier, only I'm naming this my container Posh. And just to be clear, that's not a Posh container, it's short for PowerShell. I use the same image, and then I give it a new DNS prefix, so I have that -posh on the end. So if we come over here, we can just change this and add -posh. And right now it's still spinning up, so we're probably still configuring. This is where I pull out the trick with the mouse rotation. Works every time. See that? Almost instantaneously. So now it's giving me back some information about what it just did, and over here we can see it rendered the web page. So again, just a few seconds to provision directly from that shell. Now, if I'm writing a script, realistically, what happens with these Cloud Shell instances is they get a public IP address that's provisioned to them. And in the context of a script, you probably need to know what that IP address is for subsequent steps in the script. So this is an example of a call from PowerShell that asks for this container to select the IP address. So if I run that and paste that over here, I'm asking it to query the IP address. You can see this IP address is what I got back. We can do the exact same thing from Azure Shell as well. So using that bash version, if I pop back here, I've got this echo statement. And this is doing the same thing, but instead of using a PowerShell module, it's using the Azure command line interface. We'll paste that in, and it comes back and gives me the IP addresses. And actually, you'll see I got 2 IP addresses because I just said contains the name my container, so it got my container as well as my container PowerShell. It pulled back both of those for me. So that is some of the ways that you can manage resources from the command line interface. What I want to talk about now is Azure Resource Management templates. Is anyone working with ARM templates today, out of curiosity? So a few show of hands. Is there anyone who's never heard of Azure Resource Management templates, out of curiosity? So it'll be new for a few people. So an ARM template is basically infrastructure as code. It allows you to provision Azure resources, and these resources might be infrastructure as a service like virtual machines, disks, networking components, as well as platform as a service, whether it's an app service or a container host, or even serverless functions and logic apps. All of these can be managed from Azure Resource Management templates. It allows you to group related resources together. And what's nice is with a single operation, you can deploy complex assets. For example, for a lot of the sessions that you're going to see related to Azure at this conference and on our tour, a lot of those sessions have a single Azure Resource Management template that builds out all of the components needed for that talk. One template can be used for multiple environments. So if you have production, staging, QA, you can reuse that template across, and we'll talk about how. So there's several benefits from using ARM templates. One is that it's very consistent. So instead of saying, I want you to go to a website, I want you to provision this, set up this container, et cetera, I can give you a template and have a very consistent experience that does the exact same thing every time. Templates can help express extremely complex deployments. You have deployments that have dependencies. For example, a virtual machine doesn't make much sense unless it has disk storage to launch an operating system image and to have a file system. It also doesn't make sense if there's no network interface, because then you can't connect to it. So those resources have to be created first before you can create the virtual machine. You can specify that all in the Azure Resource Management template. It will reduce manual tasks. Obviously, I can fat finger or mistype some information and accidentally create the wrong type of resource, so this will eliminate that. And they are code. The nice thing about them being code, the way we manage a lot of the sessions in this tour and at this conference, are checking those resource management templates into source control. And that allows you to have a centralized location. You can collaborate on it with other team members. You can also see the revision history if someone's made changes to that template and backtrack to previous versions. Templates promote reuse. We'll talk a little bit more about that, but they're also linkable. So if you have incredibly complex environments, you can break down portions of that environment into separate templates and have a master template that links those together for a single deployment. There's a lot of flexibility there. ARM templates are based on JavaScript object notation. So it's a format for declaring information that's very human readable. You'll see that in a second as we dive into it. And the parts of a template are parameters, variables, functions, resources, and outputs. Parameters are the first part we'll dive into. These are the things that can change from one deployment to the next. So for example, I just spun up a couple containers and gave them a DNS prefix. If you tried to do the same thing, there'd be a collision because obviously you're trying to use the same DNS name. So with parameters, we can either prompt, pass in, or even specify a file that indicates what's unique and different about each version of the deployment. In this case, for example, we might be provisioning a database, and we're setting up a parameter for a username and a password to configure for that database. The next thing that we have are variables. These are reusable variables throughout the template. I may have a network interface that's referenced multiple times by a firewall, by a virtual machine, by other resources, and so I can use that variable to reference the same consistent name throughout the template, and if I have to change it, I change it in one place instead of finding everywhere. It's been hard-coded within that template. One of the nice things about variables is they also support functions, and that's the next piece of Azure Resource Management templates. There are built-in functions that support things like string concatenation, generating unique strings, but you can also define your own function. So what this function does is it takes a prefix and gives it a unique suffix. So you may have a site that's called Tailwind Traders, and every time someone deploys it, you want to put some unique characters on the end so there's not a collision with other people deploying the same site. But then you want that prefix to be consistent throughout all of your assets. You can do that with a custom function, define that in a variable, and then reference that variable. We've got resources. This is the whole purpose of the management templates. These define resources in Azure. In this case, we're defining a network resource, specifically a public IP address. We're using a variable to specify the name. We passed in a parameter for the location. We also version this. That means if the functionality of public IP addresses changes down the road, my old templates won't break because they're tied to the previous version. And then we've got different properties that are associated with that resource. And then finally, we have outputs. So in my script, I had to actually run a query to find out what that public IP address was. I may have a set of dynamically generated assets or resources or variables that are part of my template, and I can specify a set of outputs so it generates those at the end, and I know exactly what that public IP address was, for example. So here it's actually bringing out the fully qualified domain name that was generated as a part of that template. Now you can see on the left, in this example, we've got an Azure Resource Management template. I'll dive into that. And on the right, there's a CLI that does the same thing. You can do the same thing from the command line interface and from a shell script as you can from an Azure Resource Management template. Some of the differences, that ARM template is fully idempotent. Every time I run it, I'm going to get a consistent result. That's not the case with all Azure command line interface. They may have side effects that if I run the same script multiple times, unless I've accounted for it, I may get a different setup, a different set of resources. However, on the ARM side, the JSON can be unwieldy, sometimes difficult to write. The good news is there is a way to generate the JSON from existing resources, and I'll show you how to do that. Templates might have lots of lines of code, but they can also be split into multiple files. On the command line interface side, it uses a scripting language. Sometimes that's easier to understand and to write, easier for developers, but they can become large and complex scripts, and it might not always be easy to determine what changed from one script to the next. What I'm going to do is come back into Visual Studio Code. I've got an example ARM template. First thing I want to show you is this parameters file. So the parameter file is useful because if I'm automating deployments, I may use a single ARM template for all of my environments, and then use a parameters file that's unique to each environment that gives it the naming convention and some of the things that are different. So I might have a different username and password, for example, by environment. So I can specify that in a parameter file. This is the actual ARM template. If we take a look at that, you can see we've got parameters defined here. We've got some variables defined. And then we go into our resources. So this is a storage account with this API version. And some of these resources have this depends on. So what this will do is it informs the template that you need to create this resource before you can create that resource. It builds that dependency change. And you can have multiple dependencies in a given resource. This template, I could scroll through and scroll through. And it might be a little bit difficult to visualize. Fortunately, I've mentioned that there's extensions for everything. There is a Visual Studio Code extension. If you search for ARM, you'll see there is an ARM template viewer that Ben Coleman wrote. I've got that installed, so with my template, I've got this little eye that I can click on, and what that'll do is it'll parse my template, and it will render a visual view of what's happening. I'm going to zoom into this in a second, but I wanted to show you this little prompt is one of the reasons I love Visual Studio Code. When I open the PowerShell script, it's telling me there's an extension that I can use with the PowerShell script file, and it's prompting me if I want to install it. So it automatically sensed that you're opening this type of file, we've got some support for it, you may want to jump in and install that. So this is an example of a visualization of the template I just showed you. Makes it a little bit easier to work with. I also mentioned that you don't have to manually create these templates. What I did earlier was I created a resource group called My ACI Demo to host those containers. I'm going to search for it here, navigate to the resource group. One nice thing about resource groups is I can automatically script all of the resources inside of that resource group. So if I come over here and I look at export template, this is going to parse my resource, make a best guess at what parameters should be passed in, and it's going to generate the full ARM template for me. I'm going to just take this, actually click in here, copy that. We'll go back to Visual Studio Code, paste that in here. And you can see almost immediately it's generated a new visualization showing those different containers. So the question becomes, should I use one or the other? And the answer is you can really use both. You may run into situations where it makes more sense to programmatically manage your resources. Azure CLI can reference templates and provision templates. So you can have a mix of both sides of the equation to deploy those resources. Having said that, there is a lot of information I covered on this session. We just announced the feature of Microsoft Learn. If you're not familiar with Learn, Learn is interactive documentation. You don't have to have an Azure subscription to work with Azure resources directly from within the browser inside these Learn modules. If you go to this Learn collection, you'll find a bunch of different modules that walk through these concepts I just shared and allow you to interactively, hands-on work with those. Take a look at that. We've got a few different certifications related to what I covered, and you've probably heard this already, but if not, make sure that you're aware that as an attendee, you have access to a free certification exam. It's a very powerful benefit for coming here. These are the session resources once again. Again, you'll have access to this deck, so don't worry if you haven't captured these. I do want to talk about some upcoming sessions if you're not aware of those. The next session in this learning path will be here at 1 o'clock. That's Security Fundamentals. There's a CLI deep dive on Wednesday at 11:30, so tomorrow at Theater 6. It's by the debug bar. And then on Thursday, there's an Infrastructure as Code session as well. Be aware of those. I am going to hang out a little bit. We've got about 40 minutes till the next session, so if you have questions, feel free to come up. I'll be happy to answer them. Thank you for spending your hour before lunch with me. Appreciate everyone.